This problem is about comparing the heat loss over a electrical wire with and without insulation. Okay, here we are given with the diameter of the electrical wire and the insulation thickness. So, and the thermal conductivity of the insulation and the heat transfer coefficient of air over the wire are given. Okay, so the surface temperature of the wire is given as 320 Kelvin, and the surrounding air is available at 320 Kelvin. This is 420, this is 320 Kelvin. Okay, there is a temperature difference of 100 Kelvin available. Okay, so we need to compare the heat loss per meter of wire length with and without insulation. Okay, so this electrical wire and there is a insulation. For the case without insulation, that means this insulation is not there. So for that case, the heat loss is simply by convection. So the convective heat transfer coefficient is available, and the area which is available for heat transfer is simply the pi dl of this thing. Okay, pi dl of this thing. So pi value is given as 3.14, and diameter of the wire is given as 2 mm. So in terms of meter, it is this much. Okay, and pi dl is given as, of course, 1 meter. So we can simply get this rate of heat loss without insulation, which is as 15.7 watt. Okay. Now, for rate of heat loss, of course, this is without insulation, and this is going to be with insulation. Okay, rate of heat loss with insulation. So for with insulation, we have two resistances. One is going to be the resistance of this insulation, and the another is the resistance of the surrounding air. So simply, rate of heat loss with insulation is equal to delta T by R. R is made up of two components, the insulation resistance plus the air resistance. Okay, so this insulation resistance is thickness of insulation by this K into area. So resistance is directly proportional to thickness, that you can easily understand. And if the conductivity is more and this area is more, resistance is going to decrease. Okay, so this resistance and area and conductivity have inverse relations. Okay, that you can easily understand. So this area is going to be a log mean area because of the cylindrical surface. So for which this log mean area is outer minus inner by ln of outer by inner. So this area is going to be pi dl. Okay, because of this cylindrical surface. So this L is already given as 1 meter, and this thing is now coming to this much. This inner diameter of the this material is 2 mm. Okay, over which we have 2 plus 2. There is total is going to be 6 mm. There is a outer diameter with insulation. Okay, so this is in mm, and convert that to meter. And ln of this. Okay, we are having this much. Now this is a insulation resistance, and like that insulation resistance of the air, which is simply 1 by h into a. So this is area of the this outside area of the this insulated wire. So for which pi d into L, the d is 0.6 mm. Okay, so this is in meter. So of course units I didn't write. Okay, no need to worry. So this rate of heat loss with insulation is now the delta T by resistance. Simply add these two resistance. So we are getting this much as the rate of heat loss with insulation. So with by without insulation is coming to this value. Of course, what we are seeing is actually rate of heat loss with insulation is more. No? With insulation is 2.58 times without insulation. And normally we expect heat loss to be lesser with insulation, but why this is appearing to be higher? So let us find the reason for this. For this wires of low radius or low diameter, so we have a concept what is called as the critical radius. So till the critical radius, any addition of insulation is going to increase the heat loss, and only after the critical radius, the heat loss will decrease. So let us find the critical radius for this case. Of course, critical radius for cylindrical surface are given as K by H. K is the this thermal conductivity of insulation. H is the outside heat transfer coefficient. Okay, so here the K is given as 0.5 watt per meter Kelvin, and H is simply 25 watt per meter square Kelvin. So from that we are getting this critical radius as 0.02 meter. So here, what is the radius of the bare wire? That is simply 1 mm. Plus 2 mm. No? There is a diameter, so 1 mm is the radius. So it is 0.001 meter. So here we can easily say that this critical radius is higher than the radius of the bare wire. So because of that, any addition of insulation of course is going to increase the heat loss till the critical radius. After then only heat loss will decrease. So that's why here the heat loss what we see is actually higher with insulation than without insulation. Normally we'll have this kind of arrangement for electrical wires because we need to have electrical insulation as well as heat loss. Heat has to be dissipated very fast. So that's why normally electrical wires are chosen with a insulation having critical radius, which is actually critical radius is found to be higher than the radius of the bare wire. Okay, so here the critical radius is 0.02 meter, whereas the bare wire is 0.001 meter. So the risk here, the critical this electrical wire is having the purpose of electrical insulation as well as it is also dissipating heat at a faster rate. Which is also needed here. Now, what is the heat loss here? What is the heat generation? Which is simply I square R. Because of the resistance of the wire, we have what is called as I square R. There is a heat generation. So this heat has to be dissipated at the faster rate. So that's why normally we choose electrical insulation to have this RC higher than RB. Okay, but normally for thermal insulation, say in the case of steam pipes or anything, we'll normally expect this insulation to reduce the heat loss. So in this case, how in what way? Suppose you want to reduce the heat loss, what should be the thermal conductivity of insulation? It should be, say we can use this. No, so the radius of bare wire is 0.001 meter. So you equate that, no, K by H to this value. So by that way we can choose this K to be 0.025 watt per meter Kelvin. So if the electrical wire is having this or lesser conductivity, this addition of insulation will actually lead to reduction of heat loss. Of course, here what we have is 0.5 watt per meter Kelvin. So since this is higher than this value, definitely heat loss will increase till the point what is called as the critical radius of insulation. After then only heat loss will decrease. So suppose you want to have insulation to reduce the heat loss, we need to have this range. Okay, hope you have some understanding about the concept of critical radius of insulation. So this is very applicable for smaller diameter wires. So normally these electrical wires are normally of smaller diameter, and sometimes these pipes, small pipes of the order of about 1 inch, 2 inch. Up to that, this critical radius is having very much effect. After then, this say for diameter of the pipe, like some 3 inch or 4 inch pipe, normally they will approach like a flat surface. So any addition of insulation will actually reduce the heat loss.